right, this next section of 37.3 is going to cover questions 5 through 7, but I want to start with this preview on the previous page. It says data can be distributed in different ways. We can have the majority of our data can be grouped to the left. That means it's skewed right. It says the majority of our data can be grouped to the right, which means it's called skewed left. And the majority of our data can be grouped symmetrically around the center. This is what we call normal distribution. It says in a normal distribution, the data values are grouped symmetrically about the mean, which with most of the data values occurring near the mean because of the shape, a normal distribution is sometimes referred to as a bell curve because it's got like this bell-like shape. Keep that in mind as we go to the next the next page. Here again, I'm going to work 5 through 7 with you, okay? Many real-world data are approximately normally distributed. For instance, height, weight, grades, blood pressure, time people spend sleeping. Because so many data sets can be modeled by a normal distribution, a table of values is used to analyze and make decisions about normally distributed data. For this to be accomplished, the data values are converted to scores that can easily be compared. This is called standardizing. A standard score means that the data have a mean of 0 and a standard deviation of 1. Below is a list of hours slept by a student in Mr. Trent's class. Calculate the mean number of hours these students slept. So remember to calculate the mean. What we're going to do is we're going to add all of our numbers together. So we're going to say 2 plus 4 plus 5 plus 6 plus 7 plus 7 plus 7 plus 8 plus 9 and plus 10. And there were 2, 4, 6, 8, 10 kids in the class. So once we add these all up, we're going to divide by 10. Okay? I'm going to grab my calculator. Hopefully you do the same. And so I'm going to do 2, 4, 5, 6, 7, 7, 7, 8, 9, 10. I got 65. And 65 divided by 10 is going to give me 6.5 hours. So the average number of hours that the kids in Mr. Trent's class slept was 6.5. Let's take a look at 7. 7 says, find the probability that a student in Mr. Trent's class slept more than 7 hours. Well, we're going to look back at this data. How many of these kids slept more than 7 hours? Well, I can't include the 7. So I would have to include the 8, the 9, and the 10. So that's 3 students out of how many kids were there? 10 total. Or if I wanted to do this, I could either say that this is 0.3. And if I wanted to do percentages, this is 30%. So 30% of the students slept more than 7 hours in Mr. Trent's class. Below is a graph of the hours slept by Mr. Trent's students. Dashed vertical lines have been drawn at one standard deviation above and below the mean. Now, remember that the mean was 6.5. So we're going to go one standard deviation to the left, one standard deviation to the right. It says, and notice that we had the kids that slept the 2 hours. There was only one of them. The kid that slept the 4 hours, there was one of those. 5, 6. Remember that there were 3 at the time of 7. So 1, 2, 3. We got the 8, the 9, and the 10 accounted for. It says, calculate the percent of students whose time spent sleeping is within the dashed vertical lines, okay? So We have 5, we have the 6, we have the 3 sevens, and we have an 8. Okay? This is outside of the lines. This is outside of the lines. So we've got 1, 2, 3, 4, 5, 6 kids represented in this section out of how many? Out of 10, because there were 10 students total. So that is either 0.6 or written as a percentage, that would be 60%. I'm going to stop here for a moment because that's the second chunk.